This is the right answer, but something is not working out because the V, if that's 0, then the VB, how can the VB work out? The VB needs to equal the VB. But I know that this is the answer. This is the angular frequency at which they charge each other up. It goes back and forth. So I'll look at this and I'll see later on. There's probably some glitch I have here where CVB omega squared 1 over C it's probably somewhere there's a little glitch where the VB stays by itself and it's equal to the VB and then the LCW squared. This one cancels the time dependence. Okay? So this is the radial frequency at which they charge each other, and if I want to know the angular frequency, the regular frequency is 1 over 2 pi square root of LC, and then the period is equal to 2 pi square root of LC. Now I go back to something we discussed last time. Remember? I said if I stretch this, let it go, goes back and forth, spring constant K, mass M, right? And I said the electrical analogy of this, the spring is replaced by the what? I said the spring is replaced by the capacitor, right? But 1 over the capacitor, right? So we discussed all of that last time. And then the mass is replaced by the inductor, right? So the mass takes like the electrical equivalent, the mechanical equivalent of the inductor. The electrical equivalent of the spring is the 1 over C. So whatever equations that we used in physics 1, we should be able to replicate it here in physics 3 by that replacement. So what were the equations in physics 1 in chapter 15? This is a good review, quick review of chapter 15. Well, the equations were the omega was square root of K over M. This is so lovely because it all falls into place now after 3 semesters of physics. So they wrote the mass and the spring keep giving energy to each other. And then the energy is kinetic energy plus potential energy of the spring needs to equal to the maximum potential energy of the spring when it's at its most stretched position. So the kinetic energy of the mass plus the potential energy stored in the spring is equal to the maximum potential energy stored in the spring, which is half Ka squared. And from this, you can derive an equation for x at any value. X is equal to, it's going to be 2 cancel. It's going to be Ka squared minus mv squared over Ka squared minus mv squared over K square root. In other words, if I know the velocity at any point of time, and I know the A, that will tell me what the X is. Or if I know the X, I can predict what the V is. So now let's replace that with the equivalent electrical equations. Look how nicely it falls. What should the omega be? Well, K is replaced with 1 over C. M is replaced by L. There you go, which we just derived, right? So therefore, what's the kinetic energy? Half. What should I replace the M with? The M is replaced by the L, and the K is replaced by 1 over the C. Remember that. So the M is replaced by the L. What's the V replaced by? V is the rate of change of x, right? V is dx dt. V is replaced by I. I is dq dt. Plus half K is replaced by 1 over C. X is replaced by the Q. If you ask me what is one of my favorite topics in physics, I say it's the topic of symmetry. You can boil down the laws of physics into laws of symmetry. And the scientist who discovered this was a female scientist in 1930s. I believe her name is Noether, and the principle is called the Noether principle. The law of conservation of momentum is the symmetry in space. Conservation of energy is symmetry in time. So what we're seeing is here symmetry between electricity and mechanics. And then the x is the q squared. Remember that formula? Q squared over 2c is the energy, potential energy stored in this capacitor. So that should equal to A is the maximum, what would that represent? The maximum stretch amount. So that's the maximum charge stored in the capacitor. K is replaced by C, by 1 over C, 2C. So in other words, this equation can be used to predict what the current is if you know the charge at any point in time. Or if you're given the current and you know what the maximum charge is, it can be used to find the charge at any time. Either way, you know. So I could solve it for Q, and I can say Q is equal to Q max squared, okay, over C minus I squared, Li squared, okay, and then multiply everything by C. So here's what it'll look like. It'll look like LC and then square root of that. All right, so this is the equivalent of that, right? Because K cancels, so that's your Q max squared. M over K is LC, you see? So if I know the current at any time, then I know the charge at any time. You can combine the two. So here you go, all of physics, we went around and we came back to the same, the symmetry. Okay, next time.